Like all waves, seismic ones transfer energy from one place to another, and they can vary enormously in magnitude. You create small ones when you walk, but at the other end of the scale, the ones associated with earthquakes have the power to cause catastrophic destruction. And if seismic waves are produced under the ocean, they can create vast tidal waves or tsunamis, like the one that struck Japan in 2011. Studying seismic waves at different scales helps us predict the onset of volcanoes, identify the location of earthquakes, and find out about what's going on underground. It might look like some kind of strange ritual dance, but geophysicists Jim and Roger are in fact creating seismic waves. It's part of a survey to find out about the nature of the ground under this playing field. Unlike light waves and radio waves, seismic waves can't travel in a vacuum. They can only travel through a medium. That's because they vibrate the particles as they move through it. But like all waves, they have three main variables. First, waves have amplitude. That's a measure of the maximum amount of displacement they cause. In this case, that's the displacement of particles in the ground. Next, they have a time period. That's the length of time it takes for one whole displacement cycle. You can use time period to calculate a wave's frequency, or the number of complete cycles per second. It's measured in hertz, and is calculated by using 1 over the time period. The other variable waves have is wavelength. That's a measure of the distance between points of maximum displacement, or the distance between wave peaks on the graph. They might have the same variables, but different seismic waves move through the ground, displacing the particles in different ways. And that's why Jim and Roger use two different plates. The flat plate creates primary or P waves, whilst the H plate we've already seen creates secondary or S waves.